learning physics just got better. Hello guys, welcome back to my YouTube channel, Learn Physics Better with Blessing, a channel set up with the aim of helping students who are finding it difficult to understand the subject physics. In my last video, I said I was going to treat another amazing term, which is speed and velocity. But during my study, I discovered that I have to add another term to those two, which is acceleration. So we're going to be treating speed, velocity, and acceleration. Yes, so let's kick off with the definition of speed. But before I state the definition of speed, I would like you to know something about speed. Yes, speed is a physical property that has magnitude but has no direction. Speed is a physical property that has magnitude but no direction. And physical properties that have magnitude and no directions are called scalar quantity. So speed is a scalar quantity. Take note of that. So the definition of speed. Speed can be defined as the rate at which distance changes with time. The rate at which distance changes with time. The formula of speed is distance over time. Distance over time. And the unit of speed is meter per second. And how did we get that? The unit of distance is meters, that is, distance is measured in meters, and time is measured in seconds. So meter over seconds can further be meter per seconds. That is how we got the unit of speed. Moving down, I'm going to define velocity. But of course, I want you to know something about velocity. Velocity is a physical property that has magnitude and direction. It has both magnitude and direction. And any physical properties that have magnitude and direction are called vector quantity. I'm sure this will be sounding new to some students. Of course, I'm going to do a video on vector quantity and scalar quantity. Watch out for that video. So yes, moving on, what is velocity then? Velocity can be defined as the rate at which the distance covered in a specific direction changes with time. I'll say that again. Velocity can be defined as the rate at which the distance covered in a specific direction changes with time. And the distance covered in a specific direction can also be displacement. So further saying, velocity, the formula of velocity is displacement over time. Displacement over time. And displacement is measured in meters, time in seconds, and that brings us to the unit meter per seconds. No. Don't say speed and velocity are the same thing because they have the same unit. No, and no. There is a difference. And the difference between speed and velocity is that in speed, there is no direction. Speed just has magnitude, but it has no direction. And vector has magnitude and it has direction. That is a huge difference there. It is a scalar quantity and velocity is a vector quantity. Moving on, I'm going to introduce you to another term which is more like a subdivision of speed and velocity, which is uniform speed and non-uniform speed. Yes, from the word uniform, you should know that it has something to do with orderliness and alignments. Yes, something being just uniform, like uniform. So let's get straight to it. Uniform speed. Uniform speed. I'd like to make a statement before I define it. Yes. Imagine an object traveling at a distance of 2 meters with time 1 second. And then it also increases the distance to 4 meters in 2 seconds, and also increases the distance to 6 meters in 3 seconds. You can notice that it's just increasing in an orderly manner: 2, 4, 6, and the time interval it's using to do that is relatively small. There's a difference in distance, but the difference is just small. So yes, now let's move down to the definition of uniform speed. A body travels at uniform speed when it covers equal distance at equal time intervals. I'll say that again. A body travels at uniform speed when it covers equal distance at equal time intervals, no matter how small the time interval is. Now, going back to my little illustration, I'll make a table for that. So this is a table showing the distance and the time covered by a, let's use a car. Yes, vroom. The distance and the time covered by a car. I wanted to say time, yeah. The distance and the time covered by a time and covered by a car. Looking at this table, you will see that the distance is increasing. Yes, but it is increasing in a uniform manner. So we have 2 meters, 4 meters, 6 meters, and 10 meters. And the time is 1 second, 2 seconds, 3 seconds, and 4 seconds. Looking at this table, you will notice that the difference between the distance covered at 1 second, the difference between the distance covered at 1 second and 2 seconds is 2 meters, and also the distance covered at 2 seconds and 3 seconds is also 2 meters. That is to say, 4 minus 2 equals to 2, and 6 minus 4 equals to 2. There's a uniform change, there's an equal change in distance at equal time intervals, no matter how small the time interval is, and that is a uniform speed. Now, non-uniform speed, something should come into your head. Yes, non-uniform speed, of course the distance is not equal. Yes, the distance is not equal, but the time is still equal. Yes, it's just the distance that is not equal. So now let's get down to the definition. A body is said to travel at a non-uniform speed if it covers an unequal distance at equal time interval, no matter how small the time interval is. I'll say that again. A body is set to travel at a non-uniform speed if it covers an unequal distance at equal time intervals, no matter how small the time interval is. So of course I'm going to make a table for that. So let's look at this table. Yes, so now let's use a train. Yes, so this is the distance and the time covered. This is the distance and the time a train uses for a journey. So this is a table showing the distance and the time covered by a train. So we have here the distance. We have 3 meters, 7 meters, 10 meters, and 12 meters, and the time is 3, 6, 9, and 10. Yes, 3, 6, 9, and 10. Now, if you look up here, you'll notice that there's a difference, of course, but the difference is not equal. It's not equal at all. The difference between 7 and 3 is 4, and the difference between 10 and 7 is 3, and then the difference between 12 and 10 is 2. You can notice that the change in distance is not balanced. It's just there. So that is an illustration showing an object traveling at unequal a distance, which is non-uniform speed. I hope you understand that. Moving on, I'm going to definitely explain uniform velocity and non-uniform velocity. But before I do that, I want you to just, from the word uniform speed and non-uniform speed, let me give you like 5 seconds to think what you think, or just in your head what you think uniform velocity and non-uniform velocity will be. I'm counting down 5 seconds. Just say it in my head. Just say it in your head. Just say it in your head. 5 seconds. And that 5 seconds is over. Uniform velocity. A body is set to travel at uniform velocity if its rate of change of distance covered in a specific direction with time is constant. Yes, I'll say that again. Take it slow. A body is set to travel at uniform velocity if its rate of change of distance covered in a specific direction with time is constant. Constant can also mean equal. A body is set to travel at a non-uniform velocity when its rate of change of distance covered in a specific direction with time is unequal. One more time, a body is set to travel at non-uniform velocity if its rate of change of distance covered in a specific direction with time is unequal. To add to the difference between speed and velocity, I said the fact that speed is a scalar quantity and velocity is a vector quantity. Speed can be constant while velocity can change. Okay, I will give an illustration to that. Slow down. Sounds confusing, but slow down. Let's give, for instance, car is traveling in a perfectly straight road at speed of 30 meters per second. Perfectly straight road. That means there's no need to bend or do or move left or turn right or take a U-turn. It's just a perfectly straight road. You will say that the velocity of that car is 30 meters per second due west because it's just straight. It's just straight. There is a direction of that car. But let's say the road has a lot of potholes, and for instance the driver is trying to avoid traffic, then it changes direction. Just move. You can notice that now it has changed direction, but it's still moving, and it's possible for that speed to remain constant, for the driver to also be driving at 30 meters per second, but the velocity has changed because it has changed direction. So now the driver can be driving due west or due north. So yes, that's what I mean by speed can remain constant while velocity can change. As long as the body in motion is changing direction, the velocity of that body will also change. That is all for uniform velocity and ununiform velocity and scalar quantity and vector quantity and speed and velocity. Yes, I said I was going to treat acceleration, but that will be in my next video. This video is getting long. Turn on your notification button to see the relationship between velocity and acceleration. Turn on your notification button. Part 2 loading now. Don't forget to like, share, turn on your notification button and subscribe. Thank you.